I'm going to talk about JavaScript at 17. How many of you remember being 17 years old? It was kind of rough. How many of you remember what you were doing 17 years ago? Were you doing something that is still around and being used by a lot of people? It's kind of awkward. But the cool thing is people are using it in ways that I couldn't foresee. Like here's a little 10 to the C emulator. If you know what that is from the Mojang guys from Notch. The history is pretty well known, so I'll go fast. This is so compressed, it kind of hurts me to go through it. The funny things I'll try to say about it are that the naming is hard. So Mark Andreessen wanted to call the language we were doing Mocha. It was meant to be a scripting language, sort of analogous to Visual Basic. For the designer, the amateur programmer, the beginner programmer, somebody who wasn't necessarily professional. Java was meant to be the professional programming language. So there was always an intention to tie Mocha to Java, hence Andreessen's brilliant name. But it was trademark encumbered, so they went with LiveScript. I think the marketing guys at Netscape went to work for Windows after that, and they're all fired now. And then by December 4th, 95, we had a trademark license from Sun, signed by Bill Joy, founder. And Gosling was furious because none of them wanted the name to go to Netscape, but it did. And then AOL bought it years later. I think Oracle has it now. So doing this work so fast was important to get the language out there in Netscape 2. That was the big platform play. That was where we knew Microsoft was coming after us because they tried to buy Netscape in late 94. They offered too little money. They were sent packing. We felt like we were doomed, but we, as fast as we could, got plugins and frames and frame sets, remember those, and JavaScript, which I did, in 10 days in May 1995. And I had to do it for an internal demo because otherwise people would doubt that it was either real or necessary or both. And I succeeded. Unfortunately, I couldn't change it after that because even when you have 40 users, people don't want to break compatibility. Andreessen said the same thing happened with NCSA, HTTPD, and HTTP in Mosaic. They had quirks mode invented then because people were writing ill-nested tags and didn't want to break them. So after working on it for too long and creating what was now called the DOM level 0 or HTML5, I got pressured to take it to the standards body by my management because they were feeling pressure from Microsoft. Because Microsoft was trying to gain market share. They were coming late into the browser market. Netscape was going from 50 to 80%. Microsoft had to go fast. And they had to catch up. So they wanted to stabilize it and standardize it. And we helped do that. Sun helped do that. It was a great time. It added a few warts to the language. It fixed a few others. It was kind of a wash, but it got a standard out that other browser vendors could implement. And in this process of developing JavaScript and working with early adopters, I came to appreciate interacting with users so much that I decided to work on open source. So I went off to found Mozilla, and I gave JavaScript to somebody else to manage. And it went into a standard cycle that stalled out around the 3rd edition of ECMAScript. Mozilla kept me busy for a while, but we came back once we launched Firefox. The Ajax revolution was upon us. We rejoined the ECMA committee. We restarted standardization. And I'll be frank, I was trying to get Microsoft to stop stalling it and sitting on the web. Firefox probably helped more because we got market share and we paved the way for Chrome and helped Safari, which had already launched it, but never crossed over to Windows like Chrome did. Competition was what really forced Microsoft back, but going into the standards body trying to evolve JavaScript also kind of helped. Maybe it hurt. So we had this split committee for several years, and we reunited that in 2008, and it's called Harmony. That's the name of the agenda. It's an agenda that may spread over several specs. These ES specs, ECMAScript, is a weird name. It sounds like a skin disease. It's the European Computer Manufacturers Association. They decided they wanted to be worldwide, and European is not worldwide, so they made it a noun, so it's ECMA. The name is not really catchy, so JavaScript or JS is stuck, and it's really not clear that the trademark is defensible now, in my opinion. I'm not a lawyer. So use it in good health. We reunited the committee, as I say, in Oslo. It's an auspicious city to do that in. We healed the rifts. I was the rainmaker and peacemaker, and we created something called Harmony, which we're implementing. ES5 was the sort of first fruits. It was already underway, but we got everybody working together on it. It's in your top browsers now. It's fully in IE10 previews. ES6 is underway, and it's coming. Already pieces of it are landing under a flag in V8 in Chrome and in SpiderMonkey. And we're going to collaborate to make sure we don't expose something too early that we're going to change that will break people. So we're going to try to do cooperative development with the V8 folks at least. And I think the Apple guys too are in for this. But JavaScript has these notorious warts, and I was really amused by this. I have to show it. Who is this? Gary Bernhardt. I love this guy. I lolled a lot.
Let's talk about JavaScript. Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be? Empty array, I would also accept type error. That is not what array plus array is. Wrong. Wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone. Now, what would array plus object be? This should obviously be type error because those are completely disparate types. Does anyone know what this is? No. Close. No. Far away. It's object.
That's a string, actually.
Now, of course, because this is plus, so you can flip the operands and the same thing comes out. So if we do, what? No, that's just an object.
No, it's a string.
If you do object plus array, you should get exactly the same thing, which, as you can see, you do.
The first curly in that last line is a statement.
And finally, the only one of these that's actually true is, because you add arrays, you get empty string, that doesn't make sense. But an object plus an object is actually not a number, technically. So this one's actually right. And exactly, right? Like, what is even going on in this lab? I don't even understand what person with a brain in their head would think that any of this is a good idea. Okay. Enough making fun of languages that suck. Let's talk about JavaScript. If I say array.new 16,
oh, he's a
or
Rubyist.
just array 16, I get an array of 16 things, which it represents as 16 commas, which is obvious.
15.
And if I then join those with a string, then I get the string 16 times. This is actually the only line in this entire presentation that's reasonable. Now, if I take that string and then add a 1 to it, it interprets the 1 as, or casts the 1 to a string, and then we get wat1 a bunch of times. Fine. Does anyone know what will happen if I subtract 1 from the string? I'm assuming no one does. I'll give you a hint. Does this help? Does anyone know? Yes. Wet man. That's all I got. Thank you, guys.
So Gary Bernhardt, Code Mash, Lightning Talk, awesome. The first part was busting on Ruby a little bit. You could tell he's a Rubyist because he had array.new. It's okay. It's all good. Implicit conversions were popular in the 90s, and I fell into this trap. The Borland guys were really big on them. Perl 4 did it, and it was a big mistake. That's why all that junk happens, except for the curly brace that starts the line. That's a statement. And there's no automatic semicolon after either. It just ends, and there's a plus something else, unary plus. So I'm going to talk about the 6th edition of ECMAScript because it's coming. It's in, pieces of it are already in SpiderMonkey and Firefox. They're in Chrome and V8 under a flag. The flag will probably be removed before we finalize the standard in a year and a half. And our goals are to be better language for writing applications, libraries, and code generators, which I'm going to talk about a lot. But these are not mutually exclusive. There's no false dilemma here. And we don't want to change the language too much. I'm sensitive to people who think we're going to change it into Java or something. We're not doing that. We didn't even try to do that with ES4, though I could understand why it looked like that, and I'm glad that died. So quickly, you probably are familiar with this. Some of this is, again, in SpiderMonkey and Firefox. It's been there for like 6 years. We have a better var called let that's block scoped. We have const that's also block scoped, but you can only initialize it. We have string interpolation. If you look closely, there's a $curly inside a string. The exact syntax is still to be decided. I think that you're going to have to quote that with backticks, not with the double quotes that are shown there. We have default parameter values in that function f. So you can actually assign default values that are used instead of undefined if the actual parameter is not supplied. If you call f with only one argument, for instance, y will be 1. And that even works inside these patterns that you see there with the curly braces. Those are called destructuring, and they're kind of like the dual of object literals and array literals, and they work the way you'd expect. They work like packing and unpacking in Python. We also want to get rid of the arguments object, so there's that ... rest parameter in the tail function. That is a real array, so you can slice it. No more arguments object that you have to kind of pass to array.prototype.slice.call what. And there's a dual of ... that you can use in certain contexts like expressions where you can expand an array to be positional parameters. So this tail is being called there with ... node list, which could be a DOM node list. It doesn't have to be an array. It just has to have a length property that bounds the indexes, the 32-bit unsigned indexes that identify the elements of the array, or the array-like. We also have maps and sets. You can finally index an object by another object. This is not possible in JavaScript today. People have to mutate the object with a serial number or something awful, which isn't always possible. We also have sets, which are like maps with no value. You can add, you can do has tests. These are just APIs, but they're filling gaps in the language that are not fillable by you all. That's why we're doing it. We're not going to do things that you can do in the libraries better than we can do, because the standards committee is terrible at inventing libraries. We really want to just look at GitHub and take the best 5 years down the road and standardize that. But we are trying to support libraries, and libraries need better modularity. Right now, people write module patterns, or they use objects. They export things on objects, and it works. And you can keep doing that forever, because the language is not going to be incompatibly versioned. But if you want to use the new syntax, if you have a compiler, or if you have an embedded system that only has the new language, you can write for it. You can use modules. Here's some examples. It looks kind of like Python. It's a second-class system by default. You can reflect on these things. You can do dynamic loading. But the idea is when you write a module out of line, you say module something equals a URL, then the browser knows how to prefetch it. It can optimize it. It can do it ahead of time. We have some rules to avoid getting into synchronous blocking loads. We don't want that. We've learned our lesson. Other things for libraries are kind of like plumbing, and I won't dwell on them, but we have proxies, which are a kind of way of doing metaprogramming I talked about at JSConf EU 2010. We have weak maps, which are like a map that doesn't leak. So you can have cycles inside it. You can have cycles going through the heap, and it won't leak. And now I'm going to talk about code generators, because this is important, and I think we're finally ready for it. I don't think I have to sell this, but you tell me. There's some controversy about things like CoffeeScript, and it used to be no one wanted to have a build step. You wanted to shift reload, which is awesome. I like it. But people have build steps nowadays. It's well remarked upon. Rebecca Murphy's great blog post the other month said this, and people started with minifiers and packers and linters, hinters, friendlier lints, and now we have preprocessing languages for CSS, because that needs help too. And then CoffeeScript, which is doing very well, and it's Ruby on Rails 3. Why would you compile to JS? You want to give people freedom. You want not to make them all use JavaScript syntax, which I kind of rushed through. So I used the fat 8-letter function keyword. Why was that? I think it was because of awk. And it's hard to change. We're trying to do shorter syntax in ES6. It's been a struggle. If you want to use CoffeeScript, you get really short arrow functions. We're actually putting one of those into ES6. There are other things. ClojureScript's logo is up there. There are other languages that you can look up from these slides. But this is just a taste. On GitHub, there's like 100 languages that compile to JavaScript. I think one of them not on GitHub is Dart. And it's well remarked that JavaScript is the x86 of the web, or the assembly language of the web. I don't agree with either of those metaphors exactly. People hand code JavaScript and will continue to do so, but there's something to it, especially the x86 part that became ubiquitous. The problem with x86 is that on mobile, ARM is killing it. I have friends at Intel. I hope they do well, but right now ARM is king on mobile. So it looks like hardware can actually change the instruction set architecture more easily than we can get the web to stop using JavaScript. Believe me, I wouldn't mind JavaScript being replaced, but it looks like it's going to be very hard to dislodge. And so people are compiling to it, and one of our agenda items is to make it a better compiler target language. People say, why don't you have bytecode instead? Well, remember this? That failed. It failed so badly that, according to Brian Krebs, security blogger, former Washington Post columnist, it's #1 paid for malware vector, Java. You don't want it on your Mac, because Apple took way too long turning it off. And so here's a quote from my pal Doug. Doug once contacted me on LinkedIn, and I looked at his title on LinkedIn, and it said, "The boss of you." And I was like, what? But he makes a good point here. Java's bytecode verifier can be like quadratic or even fourth power complexity. It can get really slow. It's complex. JavaScript's parser has been tuned by brutal competition among the browsers, for which I have scars, to be very fast. And people crunch JavaScript down to be small. You can still view source it. You can beautify it. You can probably go back to GitHub and find the real source because of the open source code culture. So JavaScript is the bytecode. I think it actually wins because it's higher level. You can translate it to new architectures and do better optimizations over time without getting married to a low-level bytecode like Java did. Java used to say, well, we can't change the language because of the bytecode. And then they changed the bytecode anyway. They got in trouble that way several times, and it hurt the language, in my opinion, compared to C#. So if JavaScript's the new bytecode and people like writing it by hand, then we're stuck with this dual agenda. We have to make the language more usable and fill in gaps and let the library writers do the rest of the work so we can put the standards body out of business. And we have to make a better compiler target. So let's focus on that. But keep that in mind. I'm not talking about just the better compiler target. It's not one or the other. It's both, yin and yang. I guess the hand coding is the yang. And so here we go. People want goto. They say, I need goto. I want to jump to any point. I think Opera supported this in order to run an old adventure game in the browser. And there's a challenge from Google called native client, though I don't think it's ever going to be in other browsers. I don't see Apple adopting it. I don't see Microsoft adopting it. I don't think Mozilla can afford to adopt it, though we've been pressured to a little bit. And it's impressive engineering. It's good research. It's like the state of the art. It uses some clever techniques, especially on 32-bit Intel, to have good performance. On other platforms, the performance is more challengeable by JavaScript. It's not portable. It's not specified. To make it a standard that could be implemented interoperably in a clean room would take years, maybe a decade. The view source thing, people say, oh, view source is dead. Kind of. And you could probably decompile the native code, but JavaScript has an advantage. It's still more accessible. There's that code culture I mentioned. I think that's contributed to by view source. People want to show their code on GitHub. JavaScript can sandbox too. We don't need native client. We already are memory safe. We have control flow integrity, modular browser bugs. We need to have a model for native code like C and C++ code that's a memory model. And we can do that with something called typed arrays, which were introduced with WebGL, part of the Kronos group effort. Finally in IE10, so they're going to be in all browsers. Here's an array buffer that's a typed array constructor being called. You can make a giant one, give it a bunch of memory, and you can start compiling C or C++. And that's what Emscripten does. This is a project by Alon Zakai of Mozilla Research. It's awesome. I'll show a demo. This is a port of a Sauerbraten 3D game engine from Cube 2 via Emscripten. The project's called Banana Bread. There are very few source changes. It's almost all working on the LLVM-based compiler that generates JavaScript from C++, if you can wrap your brain around that. And it takes a little bit to get started. I'm not a skilled gamer anymore, if I ever was. So also the guy who did this is an awesome hacker, but he's not an artist, so he threw together this art because everything else is copyrighted. There's some kind of evil squirrel here. This is real time. We're getting good frame rate, 60 frames a second. What does it say? Oh, right. This is no plugins. The game guys are going to love this. If I go off the end of the world, I die. Here's some water. I sink. I think I must have oxygen. I don't think I'm going to die. Let me out. Let me out. Help. And what's really cool is there's an editor built into this. This is Sauerbraten is an excellent game engine. I'm praising it. The fact that it runs in JavaScript in real time. Let's see if I can edit this. Yeah. So you can start building the world. And you can shoot things, I think. If I get out of this game and change my weapon, I'm going to blow myself up. Enough of this. All right. So native games, AAA 3D games with WebGL for rendering, with fast JavaScript and a typed array for memory, written in C++, written in C, even other choices. Let me get back to my talk. So that's Banana Bread based on Sauerbraten, showing off Emscripten. There's also this project at Mozilla Research called low-level JavaScript. Looks a little bit like C and JavaScript mashed up. Again, it's using the same kind of techniques. A typed array for memory. It's memory safe. And we're hoping to, again, show that you don't need native client. You don't need this complicated compiler and plugin and a big set of APIs that are essentially chromium.org subversion. You don't need that. You can run this on your iPad, where I don't think native client will ever run. And so low-level JavaScript is a language that takes JavaScript, removes the var declaration, uses only let for block scope, because it's saner and more like C. It uses optional types like int, but these are just machine types. You can make structs of them, you can pack them, and you can do things like malloc. And the cool thing about this is when you lay down memory in a typed array, you can view it through different widths of storage. You can make a heap and a stack. It's like my first computer that I worked on when I was younger. And the performance is really pretty good. Like this page says, allocating using this malloc from K&R, from the old C book, this is not going to be a competitive malloc, is competitive with allocating objects using the V8 garbage collector. And this is a code mirror project, so I'm going to run this demo here. It does some timing. If I just command enter it, I believe it will run. And it will show me that we can actually allocate, like, I think it's 250,000 structs 10 times. We can do this not as fast as native code, but getting close. You can see, you can taste it. We're going to hit that. We're going to get close enough to compete with native code. And the web has wider reach than any particular CPU or native platform. So this looks promising to us and a bunch of game developers. What's missing? I've talked about types. People are scared of types. I don't think types in a static sense can ever come to JavaScript. We tried with ES4. It's very hard to make the dynamic and the static worlds bridge together in a way that's both efficient and understandable and actually sound. So this is our reaction whenever we see what people think of as the bad types, like the weak type systems in Java that don't really do a lot, where you have abstract, singleton, proxy, factory bean, impl. We don't want that. But we already have typed arrays. They're good for low-level WebGL programming. There's nothing wrong with them. It's runtime, dynamic constructor. The notion of type here is simply to let the JIT, the optimizing just-in-time compiler in all the top JavaScript engines, see more about native types than it can deduce just from the JavaScript source. So you can do typed objects. This is an ES6 proposal called structs, or binary data. You can make structs containing arrays of structs. You can pack things together. You need this to talk to the GPU. You also need to represent file formats that you're deserializing from GIFs and things like that. This is somebody's picture of how the JIT compilers work. They always try to look for the particular type you're calling, even if you're duck typing. So there's a platypus, giraffe, elephant. I don't think there's a duck there. If you give them this machine type information, they simply can do a better job, and they can go almost as fast as native code. Maybe it's almost as fast so you wouldn't notice. We're also doing another project. This is an independent project we're bringing into Mozilla, I hope, to take JSIL, a version of IL to JavaScript. This has been done by Microsoft Research before, but Kevin Gadd has built his own. And there's a Bytown Lumberjack. It's kind of a bloody game. You kill raccoons and stuff. But it's another game that plays really well when you take this language, C#, map to the .NET runtime, and instead you map it to JavaScript engines. And you do the same thing with the graphics from the XNA framework that Microsoft has to WebGL. So games are coming. There's also a project at San Francisco State University. Arno Pruder is a professor there. He's also associated with Deutsche Telekom. This is a cross-compile mobile apps. You can take different mobile apps like Android ones, and you can press a button, and out comes the web, or out comes Objective-C if you want to try porting those to Apple. I don't know why you would do that. But this is very promising, and it looks like you can get more app portability this way. You won't get apps that have to be written only one by one for each of the popular mobile platforms. There's a problem with these compilers. They often tend to produce something that's not quite good enough, but I think things are converging, so we'll see. Parallelism is also important. Our hardware is massively parallel, especially in the GPU, and JavaScript is single-threaded, so what can we do? I showed River Trail last year. You've probably seen it in the video or on my blog. We have ways of taking the famous map function, map-reduce fame. The array extras have them in JavaScript, and mapping it onto a parallel array that's immutable. So you always generate new results, and you can easily, without any type system, without any static nonsense, you can easily parallelize common code patterns. And this is an example that takes something to grayscale and then colorizes it with one color. tinting. We have another project called Parallel JavaScript that is more like lightweight workers. It's a fork join model. That's another research project we think is promising. Sometimes you want both. You want to use data parallelism and you want to use task parallelism. So my punchline is that the web is still the widest platform. People complain it's never good enough, like Joe Hewitt famously blogged a few years ago, and I agree. I don't think there can be a benevolent dictator for the web, not in the current market structure. I try to be the benevolent non-dictator of JavaScript. We're making it super fast, and we're adding the missing features and filling in the gaps for programmers. We're doing both. So here's my punchline. Good old Wesley. How about applause for him? Thanks.